I'm going to talk about the Globus project, which is funded through Department of Energy, NIH, NSF, and so on. And discuss, so most of it is sort of presentation. I'm going to talk about the tools that we have targeting research data management. And then towards the end, I have a few slides that has some hands-on exercises that you could try. So you could sign up for the service and try to move data or potentially to the ALCF resources that you guys have accounts on, and try a few things that I'm actually presenting today. So start with motivation. So we're looking at some of the key use cases that researchers face when they are trying to manage some of their data, right? So I'm going to lay out 4 of these. There are many more. This will sort of lay the foundation for the tools and discuss how we are addressing some of these, right? So if you're out at your institution, you're running simulations or you're collecting experimental data, there is now, with the volume variety of data that's going on, there are a significant number of operations that you would need to do, which are more sort of a means to an end for a researcher. It's really not the research aspect of it itself. It's just things that they have to get done so they can actually get to the science. So one of the use cases you see is I need a good place to archive or back up my research data or even store my research data. We see a variety of levels at which this happens. You see people in departments who just have disk drives there that they put data in, to people who have higher level resources, potentially a campus providing resource for you to be able to store it in an archive, preserve your data, mass storage, and in some cases, people have moved to Glacier and other cost-effective storage for backing up or archiving their data. And the second one we often hear is needing to sort of move or replicate or mirror parts of their data for various reasons, right? You could look at use cases where somebody needs to move a subset of their data to be able to visualize it, so they're having to move to a different center which has the right infrastructure for them to do that. Or you're looking for machines with GPUs to do particular kind of compute. And then there are people who have allocations. So here in the US, you have XSEED, which is this National Science Foundation's computational infrastructure. It is distributed. So depending on your allocations, you might have to move data out there. So there's various reasons of why people are required to move either subsets of data or almost all of their data to various places to do compute or share with users, right? And the third use case we see is sort of this notion that almost everybody is working with somebody else on another institution. So it's a very collaborative operation in the research world. So you have users at various institutions, security domains that you're working with that you need to share data with, right? The most common way it is done today is just to give data access to somebody, you end up giving them an account on your system so they can come and touch the data and access it. So the premise here is if you do not have to compute on that resource. So if, for example, somebody has data at ALCF and they want to share it with me, and I have no reason to leverage the compute resource at ALCF, then we shouldn't necessarily have to create accounts for them. So how can we make it trivial for them to just say, here's a subset of data, go off and be able to use that, right? And then the fourth one is quasi a sub-use case of what I've described, but there are unique enough and niche enough users here that it's worth calling out, are these people who use experimental facilities, right? Light sources, neutron sources. Argonne has one, the advanced light source at Argonne. So if you look at these, the corner case of these user facilities is where people come in, they have very limited time during which they have access to the facility. So they want to be able to collect data, very quickly do some preliminary analysis of the data, potentially share subsets of the data or results with their collaborators or even people back home per se, people who don't have access to the site itself, and be able to move the data out where they can do further processing and so on. So you have this huge user facility driven need to be able to move the data quickly or share the data with your collaborators to get out of the facility itself, right? So the challenge for us was, how do we look at this and say, how can you manage the research data as easily as you do other things, right? Flickr or Netflix example. So we very trivially, as end entity consumers, leverage these services without much effort from our side. So a quick background here, while I move to the next slide here. As a team, we've been providing sort of capabilities for researchers in terms of managing data, transferring high performance transfers for data and then looking at distributed compute for a number of years. But we came at it from providing the infrastructure itself. So we sort of developed the servers, developed the infrastructure that does that. But then if you look at it, there's a big gap between that and the consumer, right? So just like you could go to a browser and be able to stream videos or look at movies, how could you leverage those infrastructure pieces that we have developed without having to put in a lot of effort, and how can we build usability? So that sort of was the challenge that we took on about 5 years ago. So out of that came a bunch of services called the Globus services, which provides big data and sharing, so big data transfer and sharing, delivered as software as a service. So we took a leaf from a lot of the commercial, and off late I'm seeing a lot more research services also, where these are provided as hosted solutions, right? So you access them using very easy interfaces like a browser or an API, and not worry about installing it yourself, operating it, upgrading it, and so on. So delivered as software as a service. That is simple, secure, and fast. These are pretty key words, right? So simple is really where the usability comes in. If you look at large efforts, research efforts that have gone on, they put in a lot of effort into the IT solutions. So they do their own scripting solutions, they build their own portals to provide these basic infrastructure. But if you look at an average researcher who's not able to invest at that level of an IT, for them the usability becomes a big pain point, right? Moving data, they would have to babysit their data transfers, they would have to worry about restarts and so on. Second one is security. Unlike the commercial world, commercial world, lot of use cases, they live within their firewall and life is good, right? But if you sort of look at the research world, where we are crossing security domains often for collaboration purposes, but yet have to respect sort of the security of each of the facilities and so on, we throw a different set of challenges when it comes to securing what you're doing. And then the third one is fast. The research world is blessed with really good networks. We have, just in terms of bandwidth capacity and what we can carry is pretty high. So the question here is, how can you leverage that, right? Without the end user having to fight it, how can we just leverage the most out of the bandwidth that we have? And then lastly, do all of this from your own storage system, right? So while we are seeing some adoption of people moving things to the public cloud, a lot of the researchers we work with have allocations, have storage at their local institutions. So being able to provide them a solution that doesn't require them to replicate their data out just for the purpose of sharing or just for the purpose of being able to collaborate keeps their costs down and becomes more effective for them, right? So we've been doing this for about 5 years now. The service is being available as production, where we are trying to provide this as a service to the hosted service to the researchers. So I'll talk about what this actually means for an end user here, right? So the first one is reliable high-performance transfer. So the user comes to globus.org, which is a hosted service. So it just comes in through a browser and initiates a transfer request to move data from a source to a destination, right? So let's say from Argonne Leadership Computing Facility to Oak Ridge, for example. Globus mediates and manages the transfer end-to-end. The data itself flows from the source to the destination. So the data still uses all the bandwidth between Argonne Leadership and the Oak Ridge Leadership Facility. Globus, the hosted service, manages the file transfer. So what does it mean to manage a file transfer, right? First, it gives you a fire and forget capability, right? So you can submit the transfer and walk away. So it does this asynchronously for you. Second one it does is auto-tuning. If you look at file transfer capabilities, the client sort of sets a lot of the parameters that determine how much you're using the bandwidth itself. So you want to hide this from the users and make it easy for them. So we sort of detect the sort of data that you're moving, file sizes, and auto-tune the transfer. So you're getting the most out of the pipe between those two, the source and the destination. And then automatic fault recovery. So if you have network blips, if you have quota exceeded errors, or some cases errors where we can recover from, Globus sort of does the automatic fault recovery, right? We pick up where we left off, we do restarts of partial files and so on. So it sort of worries about making sure the transfer is completed. And then also does automatic checksums on the files. So as soon as the file reaches the destination, we validate that the file is the same, the bits are the same end to end. If not, it auto transmits it, right? So it just automatically retries the transfer and moves the file over again. And then there's also security integration. So one of the principles in Globus here is that we sort of leverage the local security of the site, right? So the site has a particular login or a particular way they need username, password, one-time password, or what have you, then we just sort of layer on top of it and still enforce the same level of authentication that is needed for that user to access the data. So you'll see some examples where we just use LCF's login or your university login to just access the data without requiring to do additional things. And the last part here is interesting. So we have a website which about 95% of all our users come to the website and use that for transferring data. But we also have a bunch of power users who like to script or programmatically integrate, right? So I'm running this workflow every so often, stage the data. So all of this is built as REST services that are hosted and operated. And so you can directly access the service and use that using the API or using a scripting interface to be able to ask for the file to be transferred or check status of the files and so on. So the second bit that we have is the sharing. So this was the use case where I had this slide with many logos, right? So this is a use case where a user is an institution. He has some data that he has collected there. He needs to be able to share with somebody else. So the idea here is the user selects the file or the folder that he wants to share and then sets permissions, saying he wants to either give read access on the folder or potentially read-write access on that folder to other user. Globus tracks those permissions. And in this case, the permissions are stored in Globus itself on the data source. So the data never gets replicated. But when the other user, user B, who has permissions to access the data, logs in, we check to see if they have permissions and then allow them to download a copy of the data if they have read access, right? So there is no replication of data to the cloud or elsewhere, but it allows you to sort of share your data, a subset of your data, if it's a single file or a single folder, what have you, at whatever granularity you pick with your other collaborators, right? So this system has been in production for about 2 years, and few of the sites have this enabled where a user is able to share. So classic example of its use is we have some climate scientists who run simulations on Mira at ALCF, right? But all they want to do is take subsets of that data and make it available to their users. So we have another Globus storage system that's running that has Globus sharing enabled. So he just puts the data that he wants to share there and sets read permissions to his group of collaborators. So the other thing you could do here is, as opposed to sharing with a single user or setting ACLs for each user, you could create a group and set ACLs on those. You can just say read permission to all of the group. So that's sort of a method he uses to share data, as opposed to trying to get other methods, trying to get permissions for everybody, sort of accounts on Mira to access the data, or stage it somewhere else where all of them have accounts, right? So as opposed to that, he sort of is just moving it here and setting permissions for people to access the data. So I went through a few of this. We very strongly believe in the hosted solution, sort of providing this as software as a service, where users are able to simply leverage this without having to operate something on their own. We have the web command line and REST interface, so you should be able to access all of the features either through our UX or through your command line. There's really economies of scale to achieve on the software as a service. I don't know that I want to sell that to this audience, but it's a very well-known model that has worked pretty well, right? So from an end user perspective, why do you care about software as a service, right? What do you get out of that? First one is new features are made automatically available. I mean, the idea of, you see a bug, you wait for a new version, worry about how do you upgrade, what happens to your service as you upgrade it and so on is relatively removed. I mean, the idea would be that we would fix it, it gets rolled, and you would just be able to leverage the new bug fixes. The second thing, which I like to highlight in my talks, I think it's much less talked about, is just consolidated support, right? When you host something, you have significant amount of logs, a good expertise who's sitting behind looking at those things. So many a time we are able to sort of proactively reach out and help with issues, whether if you're looking at a university that is running a data mover, we are able to talk to them about what the issue is, as opposed to having the user worry about these things, right? So you have a pretty good support team that sits behind this, which also has a wealth of information that they're able to use towards debugging those things. Then I'll come back to sort of how you can take one of the storage systems and make it a part of this ecosystem. I have a slide on that I'll talk about after I do the demo. So for those of you who are looking to use this, there are about 8,000 active endpoints. Endpoints are storage systems that have been enabled so that data can be moved using Globus. We have about 8,000 of these spread out mostly across the US and some international endpoints. So as an end user, as a researcher, you should be able to just go to globus.org, find one of these systems, and then log in with your credentials, the ones that you use to access the system regularly, and move the data. So I'm going to switch over and do a quick demo of the capabilities.
Can I have a short question?
Sure.
Once you move the data on the system, who actually owns the data?
It's still yours. You're moving it from your account on one system to another account on your system, on another system.
So, okay, so
Yeah, and the data never moves through.
with the data.
And we don't even see the data. It doesn't move through us. It goes through source to destination. So we don't see the data. We only get information like how much data is moved, what file is moved. So we sort of get restart markers that say, we moved 10 bytes of this file, 20 bytes now, so that if something happens, we can pick up and restart. But we actually never see the data itself. The contents of the file, we never see them. Yeah. Okay, so like I said, this is our globus.org is sort of the primary interface that most of our users come in to move data. There's a very simple sign up. It just will require you to validate your email address, but you can sign up. I already have an account, so I'm just going to go with this. Okay, so username, password is how you sign up. So once you do, it takes you to a dashboard page, which has this transfer files, right? So this is a very simple FTP, like it doesn't have a drag drop, but short of that, you plug in one side from where you want to move the data, and then the other side, and you're off and running, right? So I'll start with, let's say, the university cluster at Chicago. So University of Chicago has a cluster that I have an account on. So this is, and I have some data on that. So if anybody from UC is here, this is the Midway cluster. So if you notice here, as soon as I went there, it said, I can find the name. It's called UCRCC, which stands for University of Chicago Research Computing Cluster. But then it immediately says I need to authenticate, right? So here, when I authenticate, I have to authenticate with my University of Chicago credentials. We are leveraging the institutional credentials here. So universities here in the US have a single sign-on credential that's a part of some federations. So University of Chicago chooses to say, this is what I need to use to sign in. So this is my University of Chicago login, which is what I use for any of the resources there. And as soon as I do that, it's going to just list my account there, right? I'm just being dropped into my account, so that's what it is. So you can browse like you would anywhere else. We have a few other functions where you can delete, create new folders. So some file system functions are available there, right? So for the other end, just for ease, we have 2 tutorial endpoints. As soon as you sign up, you get access to two endpoints that have a little bit of space on it, right? So this is the other side. But if you're going somewhere else, let's say if you're going to Exceed, let's go to Blacklight. Now I have to authenticate with Exceed credentials, right? Which is quite different from a University of Chicago one. So it's going to take me back to the Exceed page. I log in with my Exceed credentials. Okay, so this is again my account in Exceed, right? So I pick a folder, some files, whatever I want to transfer, and then I just say transfer these, right? So as soon as I hit this is like submitting a transfer to Globus. So I can shut down my browser, what have you. This is an asynchronous transfer. The data is going from the University of Chicago to the Blacklight machine, right? So it is not flowing through Globus, but I can always go look at the status of the transfer here. So because we are constantly monitoring it. So here is a transfer. It's about halfway there, right? The data is being moved. So in addition to that, you can also do some additional options on your transfer. So for example, in place of simply moving the data, I could have said only transfer new files, right? If the checksum is different or if the timestamp is different. If any of you here use rsync, it's pretty much all the options that rsync provides to be able to synchronize 2 directories, right? You can also preserve file modification times. You notice there's a checkbox called Verify File Integrity. That's always turned on. What that means is that as soon as the transfer is done, we're going to automatically make sure checksums match, and if it does not, we're going to retransmit. And in the cases where you need to privacy protect your data, if you need to encrypt any of the data that goes on the wire, there's an option there for you to choose that. It's not turned on by default. You can turn it on for every transfer that you want to do. If you do, there is some performance hit, but you do get privacy. So this is sort of the activity monitor. So as you can see, my transfer is completed, and I can go see some details on the transfer if I want to, right, where it moved. In addition to this being completed, I will be sent an email saying the transfer was completed, right? In the off chance that I'm moving significant amounts of data, let's say I'm moving terabytes of data, or if the transfer takes longer than an endpoint credential is available, again, you'll get you'll get an email saying, we have a quota error, or if there is any error where we can auto-solve it, you'll be notified and you'll be asked to come and sort of try to fix that, right? So really quick transfer demo. So then the next one, let's see, is what if I want to move data to my laptop, right? So the examples I've showed you here are clusters or institutions that are hosting these endpoints that you want to move data between. But let's say now you have some data sitting in your laptop, or you want to download some data to your desktop machine. How do we do that, right? So we have something called Globus Connect Personal. And the best comparison to this is a Dropbox agent, right? It just runs in the background on your machine, and it converts your machine into an endpoint. So we have binaries for all the 3 platforms. So you first give it a name. What do you want to call it? OK, I already have a laptop, so let's say, OK. And then I download the binary for my platform. So this is a one-time setup, right? Once you set it up, it auto-updates on its own. So I do this. So the first time you start it up, it's going to ask you for a setup key, which is sort of what is generated here. So I paste this. So now what's happened is you see a small icon up there. If you can even see that, it says G up there. So that's just the agent. That's the Globus Connect agent that's running. Now I can just go list my laptop, right? And it's just going to list contents of my laptop. So now then it's like any other endpoint. I can move data to and from it. But these sort of installs, the Globus Connect Personals, are private installs, which means only I can move data to and from it. I'm the only one who even sees that it exists. So if you go to globus.org and try to find endpoints, you will not even see this endpoint. It's private by default, right? Nobody else can access it. Nobody else can log into it. So we call these personal endpoints. So now you can, just like I did in the other case, I could pick, let's say this Excel file, and I can move it to any of the clusters. Everything else works the same. The Globus Connect Personals can be installed without admin permissions on the machine, and it can also work with just outbound firewalls. So you wouldn't need to sort of poke holes in your firewalls to come inbound. So you could just use that as it is, right? So this is sort of a way for you to solving the last mile problem. You have these machines that are not necessarily administered as a cluster or something that's managed by a department. You should be able to move data to and from that. OK, so then next one I'm going to talk about is the sharing. So I talked about the second feature that we have, other than the managed transfer, is this ability to share data, right? So sharing is not enabled on all endpoints. It's sort of somebody who operates University of Chicago decided they want to enable sharing. So now I can go pick a directory and then say, I want to share this directory with some users, right? First thing it lets me do is give it a virtual name, right? So what do I want to call it? Something that's relevant to people I'm going to share with. So let's say demo 12, as generic as it can get. And then now I get to set permissions for users, right? So in this screen, I'm going to say who's allowed to access the data in that directory and at what level, right? So I can go search for users by the Globus username. So let's say we look for Foster. So I search for a user. I can see their email address to see if that is the user I want to share with. I select the user, and then by default, we give them read permissions. You could choose to give them write permissions, and then you set selection, right? So now what I've done is I've taken a directory in the University of Chicago Midway cluster that is in my space, and I said user Ian Foster is allowed to read from that directory, right? So now what happens is if he goes to the name that I gave it, the pointer that I gave it, I called it demo 12, all he will see are the files inside the directory, right? So he can't browse up or see any other parts of my file system. So if I go back here, these two should look awfully the same because it's actually just a pointer to that directory, right? So now because I gave him only read permissions, he can download any of the data from here, right? So it's a very simple way to sort of distribute data to collaborators or share subsets of data with your users. So the same thing that I just did for a single user, you can do for a group. So we have ability for you to create groups. So you can create groups of users and just set one ACL saying, I want to give read permissions to this group and add people to the group and maintain permissions like that, right? Okay, so then. Browsers are great. There are people who hate browsers. So here's a CLI, right? There are. So, okay, so let's do this. So what we've done is, if you are scripting, right, or if you're a person who just likes to use the terminal to do stuff, what we've done is just created a way for you to just submit commands to it. What we do is we run a hosted shell, right? So what you have to do is you SSH to the service that we run, cli.globusonline.org. Okay, and you can do absolutely everything that you can do from the web, okay? And the way this allows me to SSH is on your profile, you can go and add an SSH public key. So what I've done is I've taken the SSH public key from my laptop and just added it saying this is yet another identity for me, right? That's how we link, that's how we know you're logging into that particular Globus account. So once you do that, then if you just run man on that, you can see, for example, you can do ls. So here I could do like ls ucrcc midway. Did I type that right? Right? So this is just an ls against that, which is kind of what that file browser did, just listed the directories. So we have a transfer command that takes source destination pairs that you can use. We also have a command that just does, it's called an SCP, but it actually just submits a transfer to Globus itself. So you could just say SCP a directory to another location. You can do ls make dir. Whatever I was able to do using the web, you can do. You could also run status commands. So we have a command called status where you could say, give me the, so if I do status minus A, it's going to give me all the recent transfers I've done. And it's all machine. The idea is for it to be programmatically parsable, right? So you can say, give me only these fields and look for particular values that say succeed, failed, or what have you. So most use case we have seen with this is people sort of leverage it as a part of their workflow or as a part of their scripting to then just sort of outsource the transfer piece, but keep the rest of their infrastructure as it is, right? Okay, that's all I had on this one. I'll go back to my slides. Does anyone have questions? Yes?
I have a question, not about the scripting, but about the sharing that you just did.
Sure.
So you took a directory, I think it was on Midway,
Right.
and you shared it with Ian Foster.
Yes.
Now, when you did that, you had to log in to get access to that account. You had to provide credentials.
To Midway, yes.
Okay. So, but he doesn't.
He just needs Globus credentials.
So if I wanted to give myself access to something without having to provide credentials all the time, I could just share it with myself?
Yes. Sure. Yeah. So the operators of the service have a few controls. First, they have to enable sharing. Not everybody does, right? So Midway has. Second thing is, the Midway administrator would have said you can only share from some parts of the file system. So you'll have to be careful that you're in that part of the file system. Midway is, I think, pretty much your home. You could share from anywhere in your home. Those are the controls they have. And Midway administrator can choose to block you from sharing. Right? So the admin still has full control of who can share, where can they share from, what parts of the file system they can share from, and so on. So they have complete control over what you can share. But if all those conditions are met, if your account can share and you're sitting in a part of the file system that they've enabled sharing, sure, You can give yourself permission, and so the most you can do is copy data out. If you give yourself write permissions, you can copy data in and overwrite files. That's what you can do.
How have system administrators felt about about that?
I think the read access hasn't been a big problem, right? So okay, let's say it depends. If you're talking about LCF class of users, LCF class of machines, then yes, right? That is a big issue. But for example, NERSC has it enabled in some parts of their file system, but for read access only. So the argument there is that once the data is yours, they have no idea who you're giving it to, right? But write access is a problem because you get on their machine to put something in, right? Universities, we have San Diego Supercomputing, University of Chicago, a few others that have enabled. I don't know the top of it. So I would say they're approaching it with more caution than definitely transfer, because transfer, you're moving your files to another location of your files. And we've seen a lot more adoption for just read access than read-write access. So that's the other control an admin has. He can say, I want to enable sharing on this machine, but the user can only set read permissions. So the admin can say that.
And the ALCF machines?
None of them are enabled. ALCF does not have sharing.
No sharing, okay.
No. Yeah. So some of the researchers, like the climate scientists I work with who run simulation ALCF, we have another endpoint that's sitting at Argonne. He just stages the data there and shares from there. So yeah, ALCF, none of the machines have sharing name. Thought I saw another question at the back.
So how about accessing tapes?
Accessing tapes. Globus does interface with, so you could set up a Globus frontend to a HPSS system. We have maybe about 4 such endpoints, like NERSC HPSS has it, NCSA has it. So we have the technology to enable that. If you go to NERSC pound HPSS, that's their master rate system. Not all, like, the LCF one is not, for example. So we have the technology, we have a few endpoints that have that enabled, yeah. Any other questions? Sure.
So just to make sure that I understand this, so is it using SSH keys behind the scene to actually, when you do the sharing, because that person has pretty much logs into the account to read the data, right?
It's not using SSH keys. It's sort of, ultimately the security is done using PKI and X59 certificates. We use certificate authentication behind the scenes. So the person, when I first authenticate to RCC Midway, the authentication is my password and X509, and then I set permissions, let's say, for you to access the data. When you come and access, the system administrator sort of accepting Globus's assertion that I have set permissions for you to access. Right. So there is a trust of Globus in there, but all of the security layer inside is not SSH, it's all X59 certificates. So we have 8,000 endpoints, but that's pretty far less than where you could be moving data to. So here's how you would take a storage system and make it accessible through the Globus ecosystem, right? So we have this stack called Globus Connect Server. I met a few people who know me from many years ago, so this is still GridFTP under the covers. So the software stack is still GridFTP servers, for those of you who know what that is, with MyProxy and so on. So we're still leveraging technology that's been in production and made use for a number of years, more a decade now, right? So that's the piece that you put on your storage system and that's what is used as for moving the data itself. But what Globus Connect Server has packaged all this up to make it very simple to just install it on your machine. We have binaries for various platforms, and then quickly connect it to the Globus ecosystem, right? So if anybody here remembers GridFTP days, you would have to go get a certificate, and then create a proxy, and manage your certificate, and then submit commands to do this, right? So what we're trying to do with Globus Connect Server is hide all of this behind the scenes. So the user just uses his username, password. If you try to do this with the ALCF, it'll ask you for OTP also. So just leverage the standard authentication that you use, and behind the scenes do the certificates and all the PKI that is needed, right? So Globus Connect Server lets you quickly convert an endpoint, a storage system, into something that's available through the Globus transfer interface. So in addition to this CLI, and in addition the command line client that I showed you and the web service, like I said, this is all backed by REST services, right? So there are well-defined public APIs that back this, and you can see it's sort of layered on, right? We have the basic, how do you log in, how do you create groups sort of thing, how do you manage your credential. that's then leveraged by our transfer service, where you can submit transfers, check status, and so on. And then the sharing service that lets you set permissions to share. So all of these have very well-defined APIs that somebody can leverage. And we have seen use cases where people who have their own portals, who have their own applications, use this, right? So for example, one of the good examples is the climate community. They have a portal called the Earth System Grid, which lets you search vast amounts of climate data. They have really rich metadata. But once you select the data, right now the way you download it is use wget, right? So you have to download a wget script, and then that's kind of how you download. So we updated that portal to say, once you have selected the data, redirect the user with the data selected to Globus, where the user selects where he wants to move the data, and then goes back to their portal, right? So all we are taking is outsourcing just the download mechanism using the Globus API and the platform-as-a-service concept, so that they can keep the domain pieces that they have built and the users are used to, but they can just go out to Globus for the pieces that they really need, which is high performance and managed data transfer. So one of the things I said, we were from University of Chicago and Argonne National Labs, so most of this is funded through various grants. But then there is the operation aspect of this service, right? The grants fund us mostly for research and development pieces. So there is a question of sustaining this service. How do we operate and provide this service, provide this value to the researchers? So there are a few premium pieces to this, where mostly institutions who are operating these endpoints, like University of Chicago and these guys, they actually subscribe to Globus to get higher SLAs, mode management capabilities, being able to look at all the transfers that happen from a site and being able to throttle it and so on. So there are some plans that potentially institutions can get that provide operational costs, that provide sustainability to the project itself, right? So that's something we are ramping up and working on at this point. So I'll talk about two other things which are not transfer and sharing. So one is Globus Genomics. So this is another project out of my team which actually leverages all of the pieces that I talked about, the transfer, the identity, and so on, to provide scalable genomics analysis to the users. So you could think of them as a team building a domain-specific vertical on top of the Globus platform itself, right? So under the covers, they're using Galaxy, which is a workflow service that, a workflow infrastructure, a workflow operation service that, that's been around for a long time. They're using that to be able to do next-generation sequence analysis, but they're hosting it and operating it for the users. So sort of continuing on the software as a service theme, right? Under the covers, they're using Globus for the data management needs. So using Globus as platform as a service, right? So they use our APIs and where needed, some of our web pages and so on, but just leveraging it. And then finally, they're doing all of this on Amazon Web Service. So there's the infrastructure as a service there that they're leveraging, right? So the end value is a very domain-specific end value where they're providing next-gen sequencing across various domains, but biologists, cancer biology, and so on. But they're leveraging all these pieces to build that vertical itself. So what are we up to now? So we have transfer, which has been in production for 5 years, sharing, which has been in production for the last 2 years. So in addition to the various improvements and keeping it operational and new features that are going in, we're also starting to look at the next piece of the puzzle, if you will, on a research data management spectrum, which is sort of your metadata, right? So how do you manage metadata that goes with your data? How do you use that in all of this? So the first thing that we're working on, which should be available around November of this year, is the data publication. So again, the service as a software as a service for providing large research data publication, right? So if users have, where you end up with like an immutable data set, so you're ready for the version of a data that you want to make available to other people, but just not as files, but you want it sort of curated with metadata accompanying it, policies attached to it, and then you want to make it available to either users at large or to a subset of users. So a service that provides those capabilities is what we're working on, right? It still builds on the same principles. It's still going to be a software as a service, so you wouldn't have to download and install any of it. It's going to be bring your own storage. The idea here is that many of the metadata management services you see today is where you have to upload the metadata and the data to the service, right? If anybody in the audience is familiar with institutional repositories like that run DSpace or other pieces, you put in your metadata, but in addition to it, you also push your data to it, right? So the issues we see with that, or the use cases it does not address, is when your data sets are very large, when your data sets are distributed, then you start running into scale issues with that solution. So with this publication solution, we're saying the hosted service will allow you to upload the metadata, go through permissions, curation, and so on, but you can put a pointer to your data to wherever your storage is, right? So data doesn't move to the cloud, but you just put a pointer to, let's say, your institutional repository or a project archive without having to push the data itself. Extensible metadata, it's pretty obvious being able to support various domains where you're able to put in your own metadata schema and so on. Publication and curation workflows see a lot of interest in where the data itself goes through sort of validation, right? Is it in the right format? It doesn't make sense. Does it go through some of the QC checks, quality checks that are needed by projects and so on? Supporting public and restricted models. It's pretty often you see where a project has data that it wants to share, but only with like a subset of people, not public at large. In some cases, we get embargoed data that needs to be restricted for a period of time. So being able to support such things. And then the rich discovery model. So we're starting to do faceted searches and trying to leverage what we see as an extensible metadata. So whatever you put in there, being able to use that to discover the data itself. So the idea would be to properties of the data, right? So be able to provide a publication service that lets you have a data set that is identifiable, well described, as much as your project wants it to be, curated at various levels, right? Some projects, they really go through automated tool checks, whereas there are some projects where actually there's a human in the loop that validates that the data is what it should be. Verifiable, accessible, and then preserved. We should add another verb there, immutable, right? So you want to give it an identifier and be able to come back to the data set at a later point in time and just be able to find the data as it is. Then you look at the search, browse, and access, right? The search that we're used to in the commercial world. I mean, you could go to Amazon and put in a keyword and find data pretty well. So something similar to that, being able to leverage the rich metadata. So here's a quick sort of model of what we have. So we envision that you would have a collection, and the collection can be defined. It's just a container, right? So it could be defined across project lines, domain lines, however you see fit, which has various data sets inside it. And a data set has data associated with it, which could be files of various formats. Right now we're dealing mostly with files, but we also envision you would have other data. You could have pieces of data in a relational database and so on. And then metadata associated with it. And along with that, a variety of policies, right? What is the metadata that is needed? What access controls are needed? License, and so on. And that we have many such collections. And depending on access control policies, you would be able to search across them. Is sort of the model that's being envisioned for this. So to put this in a little bit more concrete terms, I'm going to do a very quick walkthrough of what this looks like, right? So this is sort of the Globus publish schematic, if you will, right? And you see various collections. So you have a University of Chicago and Argonne collection. So it's really what we envision, either an institution or a project defining as their collection. So a scientist chooses a collection he wants to publish data to, and there are access control permissions here. So can I publish to the collection is the first question you get asked, right? So then he describes the submission. Here is where we are working on sort of saying, other than the basic Dublin core, things that you provide as a part of the journal, the collection owner can define additional metadata you need. So for example, we've said, energy density of materials, APS proposal numbers. So at various levels, whether it's scientific or process-oriented, be able to define the sort of metadata that you need as a part of that collection. Then the third step is where the scientist actually assembles all the data, right? So there might be data sitting on machines that you computed on, your desktop, laptop, what have you. You move that data to the collection storage. A university providing it, a project storing it, that's sort of the final resting place for the data, where it's going to be preserved, archived at various levels, right? So this is sort of the scientist assembles all the data and then submits it for publication. So if you note here, the metadata goes to the cloud, so that's sort of hosted, but we just put pointers to the data in the storage system. So we are not replicating any of the data to the cloud itself, right? We're just leveraging the existing storage. So you go through a curation workflow, and then it gets accepted as a part of the collection if it meets the standards. And then we have a search interface, right? The user is able to come in and look for the data. And if he has the right permissions, he's able to actually download the files, be able to make a copy of the files to the location. So we are leveraging a lot of the Globus pieces here, but providing sort of the next level abstraction on top, right? As opposed to thinking in terms of files and directories, you're now able to think in terms of data sets, right? I need to operate on a data set. I need to be able to move a data set. So be able to operate at that level, be it in your workflows, be it how you share data, and so on. So here are some, my slides are up on the website if anybody is interested. Here are links to the main web page, Globus Genomics itself, and then the data publication, the bit that I just talked about towards the end. That's new, it's still not in production. We expect probably about November when it'll start getting being made available to the general public. So I'll take questions, but just before that, at the end of my slide deck, there are like 4 slides. The first one just talks about being able to sign up for a Globus account if you're interested in doing that. Second one talks about moving to ALCF. I've given you the name of the endpoint. So if you guys, I think all of you have accounts, so you should be able to try it out. Just move some data to ALCF. There is also a second endpoint name which has some test data on it at various sizes of test data. So if you're just looking to do some simple transfers, you can do that. The third one is the sharing. It just talks about being able to share from an endpoint and how you can try that out. And then the last one talks about the CLI. So if you're interested in scripting and you want to see how that works, you can configure it and then try it out. Okay, with that, any questions?
One question that I have with this Globus Publish, does it index the data in any way?
Yeah. So if you look at sort of the, once the submission has been accepted and it's a part of the collection, we sort of maintain an index of all the metadata. So you're able to come in and do searches, right?
Okay, so
But yes, as a part of the index though, there's also access control permissions, right? So both of us might have published the data, but mine might say, people can see the metadata, but they can't download my files yet. So you may be able to search, you may see some results depending on access control permissions. Even if you see the results, you may not be able to download my data because, yeah. So, but yes.
Like explanations and stuff like that, and then
That's
associate that with the data.
That's right, yeah. So you could put in metadata. So pretty much as far as Globus is concerned, the metadata is whatever you pick, right? So for us, it's just a key value pair. So you determine the schema, what you want, and then you put in the metadata, and we index across all of that stuff with data types. So you should be able to run searches that says, give me all materials on which the experiment has happened where energy density is greater than 1,000, right? So we actually store data type of your metadata. So you'll be able to do searches, range searches and such on that itself.
And you can organize it in trees or?
Organize what in trees, sorry?
The data or?
The search results? Or?
Well, no, like in sort of like a directory.
Yes.
The way it should be like in different, you can group it together.
Yes, you can totally do that. So for the November release, we'll only have this, but the bit we're working on as a next bit to it is auto-extracting metadata. So I'm working with a bunch of climate scientists where the metadata are in, they have a directory with tons of files under it and various subdirectories, and the file have headers in them, netcdf files, which already have the metadata. So how can we sort of just go through and ingest those things? So we're working on that being a part of your submission workflow. So once you submit, you say, here's my data, and oh, by the way, it's netcdf, just parse it and pull all the data in. So we're starting to see how we can support those things. So we can run those parsers and ingest the metadata. Okay. Sure.
You mentioned that it can be installed without root or super user.
The personal one, right?
The personal one. How about the sites where they use two-factor authentication or like dongles? Does it work in that environment, or how is it? Because they're like sometimes they use special ports and they enable only particular ports.
So on your personal machine, yeah. I mean, if your machine itself is blocked for some reason, the thing that we need are outbound ports. Pretty much, I think we need 2 outbound ports. I don't remember the exact numbers. So if those are blocked, then you wouldn't be able to use it. But if it's not blocked, then you should be able to set up personal and just leverage it. The sites that have like OTPs and stuff, we support that. So when I like logged into University of Chicago, you saw it said username, password. If it's a site that needs OTP, under that you will see another box that says give me OTP, right? So we do support two-factor authentication that way. Yes?
Is Globus planning on adding any hosting at all?
As in storage?
Yes.
No. Not on the cards, no. We support moving data to S3. So if you're sort of leveraging storage on the cloud, you can use Globus. Just like I moved data in University of Chicago, you should be able to move data to and from S3.
Yeah.
So if you use S3 backed storage, then you can do that.
We're just always looking for more redundancies.
Yeah. Yes?
If there is a failure in between, it will automatically restart or the user has to do it?
It will automatically restart. We have a concept called a deadline. By default, it is set to, I think, 3 days. But as long as the transfer is making progress, the deadline will keep moving, right? So until that deadline is reached, it'll just keep automatically retry. We have some hard faults. So for example, if you take ALCF, right? When you log into a Globus endpoint ALCF, if you guys go try ALCF pound DTN, right? When you log in, ALCF only gives our Globus 12 hours of temporary credentials to try to move your data, right? But if you're moving data that lasts more than 12 hours, then obviously it'll fail, at which point you will get an email saying this is something that we can, sort of auto-recover from. And it'll give you a link. If you click on that link, pretty much you'll be taken to a screen where you have to retype your ALCF password, username, password. Then we'll pick up from where we left off. So, if you moved 10 out of your 100 files, we'll start from your 11th file. If you've partially moved your 11th file, we'll pick up from there and move. So we can do those things, but there are some hard failures. For example, quota exceeded, right? There's little to nothing we can do without you, intervening in this. And there's various debates about, what are hard failures, what are not. But from most of so network blips, or we try to when we try to source an endpoint, let's say it's down for maintenance for like an hour or whatever, we'll pick up from all of those things. So you won't see issues with that.